All right, so now we're going to find the perimeter of triangle ABC. So realize we're just using the theorem we just used. These are all tangents, all right, coming from the same point. So 6 from B to there, that's 4. So this is also 4. And then last and certainly least, if that's 7, then over there is 7 as well. So the perimeter of this big bad boy right here is just going to be, well, this is a side length 13. This side length is 11. This side length is 10. So the perimeter of this bad boy right here is just 10 plus 11 plus 13, also known as a famous number called 34. 34 is so famous, everyone in this class has heard of that before. All right, find the length of DC, and we're going to say, well, this is a good challenge problem right here because we have to use similarity and Pythagorean theorem to find BC. All right. So really what it's saying is this right here. So this is just a combination of a bunch of stuff we've been doing so far. This is perpendicular. So this is a right triangle. We're going to use Pythagorean theorem right here to find C. So 10 squared plus 24 squared equals C squared. All right, 10 squared plus 24 squared. C squared is going to equal 676, which then you take the square root of both sides. C actually equals a nice, crisp, clean whole number, 26. That's kind of convenient. Nice. All right. Now, this is also a right triangle, and it said it's similar. All right, so what we can do is set up a proportion, well, 10 to 5. Oops, 10 to 5. Well, that ratio right there, well, we need to find BC, so that's going to be 26 to BC, equals 26 to BC. All right, just looking at this, you might be able to tell what BC is going to equal, or we can just cross multiply and solve. And BC equals 13. All right, that's the answer right there. That's how you do it. All right, oh, it said find DC. Excuse me, I didn't read the problem. So DC, if that's 13, DC, the whole freaking thing, is 39. Because you did 26 plus 13. All right. That's the true answer. BC, 13. DC, the whole thing, 39. All right. Now we're going to determine which of the following statements are false. Again, we're just going back and forth from all kinds of theorems and stuff we've been using. All right. So CK and CE, well, common external, false, not false, that's actually true. All right. Well, what about FE? Tangents coming from a common external point again, that's also true. What about CB? Again, this is going to be kind of hard to see up here, but again, that's true. So all of these statements are true. All right. Which one's false? None of them are false. They're all true. All right. Is the given line segment tangent to circle K? Well, if it is, that means this is a right triangle. So Pythagorean theorem must work. So 6 squared plus 8 squared must equal 10 squared. So we're going to get 36 plus 64, which is 100. 10 squared is 100. So since it's perpendicular, it's yes. Because the tangent is perpendicular to the radius. Cool beans. All right. Almost done. Find the value of x. So again, we did a problem like this already. Similar to this is, well, this one's a little different. It really what it wants to show you right here is this is x as well. All right. Notice how what it wants to say is, well, since these circles touch like that, that's 8 and that's 4. So this whole thing is 12. All right. And then this right here is also 4 because we did 8 minus 4. All right, that's 4, that's 4. So really what we just need to focus on right here is this right triangle. So what we're going to do is x squared plus 4 squared equals 12 squared. X squared plus 16 equals 144. 144 minus 16. X squared equals 128. Do the square root of both sides, and x is going to be approximately 11.3. All right. And then last problem is what this is saying right here is we got the Earth. So the GPS, we got some satellite. All right. It sends out a signal to a receiver on this. So this is a satellite. That's the best satellite I know how to draw. It sends a signal there. Boom. All right. 13,000 miles away. All right. The radius of the Earth is about 4,000 miles. All right. What is the distance from satellite to Earth? It's going to be that distance right here is what we want to find. So what we do really fast is let's just find this whole length here, x, and then we'll do some subtraction. So x squared, I'm just doing Pythagorean theorem, writing in reverse this time, mathematically legal. All right, gonna do a bunch of calculations in my calculator right now. 4,000 squared, 13,000 squared, the square root of it. Plugging this all into my calculator, it's about 13,601 miles, 0.5 to the center of the Earth. That means that this is 4,000. So this distance right here, which is what we want to find, just subtract 4,000 from our answer. And the satellite is this distance from Earth. It's 96,001 mile. All right, that's the nearest mile. All right, so just how they can use